Okay, good afternoon, everybody. Welcome in. Thanks for coming to the seminar today. My name is Dr. Hart. I'm a faculty in the Mechanical Engineering Department. I think many of you know that, but more importantly for this conversation, I am the coordinator of the Senior Design Capstone Experience in the department. So you'll be hearing a lot from me over the next couple of weeks, and I guess over the next year and a half or so, about all things related to senior design. So hopefully you're all here to get information related to senior design. You filled out your email, put it on the email list, and so now you're here hoping to get some information. So thanks for joining me. I am recording this, so if you want to revisit this video later, you can feel free to do that. So what's going to happen in this seminar today, we're going to talk a little bit about senior design, what to expect, how you create your teams, your teammates, how you give preferences for your projects, what projects might be available and how that's going to look, and those sorts of things all related to senior design. At the very end, too, we do have Dr. Mahinfla in the call as well. He wants to talk for maybe about 5 or 10 minutes about some of the graduate program opportunities that we have in the department for those of you that are, going to end up graduating and thinking about maybe doing some graduate school stuff here at MSOE, okay? So thanks for joining. We'll make this presentation relatively quick. We'll have some time for Q&A in the end. You can either type some questions into the chat as you have them as we go, or if you want to wait to the end and, express them verbally at the end when we're all done, you can feel free to do that. So without further ado, let's go ahead and get into it. So as a senior, you're going to work on multi-semester design projects that's going to leverage everything you learned in your classes, and hopefully you're going to be building some sort of prototype and showcasing that at the very end, okay? So let's go through this and talk about it. First off, generally, what is senior design? I think many of you have a general idea, but let's give a formal definition here. It's a design sequence. It's a multi-term sequence of classes aimed at giving you a design experience which leverages your problem solving and engineering skills you've developed over your undergraduate time. It's 2 courses. You'll take MEC 4901 in the fall and 4902 in the spring. And you're going to be working on one specific project for the full duration of that time. Usually your teams have between 3 and 6 people. Sometimes they can be as large as 8, but I'd say it's usually between 3 and 5 most of the time. Each of the project is guided by an ME faculty advisor. That could be me, or it could be a different faculty advisor in the department. And the projects that we have available are vast. We have a lot of different things. ME covers a lot of different areas and topics. And so we have a sort of a broad spectrum of possible projects. So some examples from this year that people are working on: design of an automated guided vehicle fleet. This is similar to Amazon robots that move around like an Amazon warehouse. We have design of an unmanned aerial vehicle for the Design Build Fly competition, so essentially building an unmanned aircraft for that design competition. It's a national competition through AAA. I have a team that I'm advising that's designing a carbon fiber engine block. So instead of an engine block made out of aluminum, they're trying to design it out of composite materials. And then there's a team doing a 3D printed motorcycle. So we got stuff kind of all over the place. I think this gives you a bit of a flavor of some things you might expect for projects. All right. Now, I think it's good to present the hierarchy on sort of what everything looks like from the top down. So I am the senior design coordinator, but you may or may not have a significant amount of interaction with me as we go through the process. You will certainly interact with your individual project advisor quite a bit as the year progresses. And then, as a student, you're going to be part of a team. So let's cover each of these different levels and what each person does. So like I said, I'm the coordinator. My responsibilities are to create syllabus, organize the seminars. We're going to have a seminar series in the fall. I match all the projects and students in the teams. So I'll be doing that probably in the April to early May timeframe. I collect all your written reports and archive them. I organize oral presentations. So you have to give some oral presentations of your design as part of the process. If you have a conflict with your advisor, I can step in and sort of handle and mediate that a little bit. And then part of my responsibilities are to ensure that ABET assessment is being handled correctly. So ABET is the Accreditation Board for Engineering and Technology. It's the board that licenses MSOE to give engineering degrees. And as part of my role, I have to organize some of the information as part of that ABET process. Okay. Now, your advisors. Each team has their own individual advisor, and one advisor may have more than one team. All right. The advisor generally guides the projects. They're going to maybe create some assignments for you. An assignment might be like, do background research related to your project where you look up some patents or look up some research literature or look up other products that try to solve the problem that is in front of you that you might want to copy or mimic. All right. Your advisor is going to assign your grade. So I do not assign your grade unless I'm advising you as the project advisor. They're going to meet with you weekly or semi-weekly, something like that. And then if you have a customer and industry affiliate that you work with as part of your project, they're going to maybe help coordinate some of your meetings with them. All right. Lastly, a student. You. What are you responsible for? You're doing the work. All right. You're doing problem statement, background research, objectives and constraints, proposing ideas, down selecting to best ideas, building a prototype, evaluating the prototype, testing the prototype, and presenting all that work. All the good stuff. Grace asks, are grades pass fail or are they letter grades? You get letter grades for the two classes, 4901 and 4902. So let's move on and let's talk about requirements for taking senior design in the fall. So here's a flow chart of the typical ME progression, and you'll see that a lot of the junior classes here are highlighted. You need to complete at least 2 of the 4 core ME tracks, the core junior tracks. And so the 4 tracks that we generally have are materials, energy, dynamics and controls, and mechanics. And so you must complete 2 of the 4 core areas. And that would include finishing, the manufacturing and processes class, the heat transfer class, the machine components class, and both the instrumentation measurements class and the dynamic systems class. So you must complete 2 of these 4 tracks, and I've highlighted them in a little bit more detail here. The 4 areas culminate with these courses. So the registrar checks this. So if you try to sign up for senior design and you haven't completed 2 of these 4 tracks, you're going to get the boot. So that's just the way that it is. It's like a prereq for any other class, right? You have prerequisites that you have for this class, so those must be met, and these are what they are. Okay. Now, how are the teams and the projects selected? Well, I'm collecting projects right now, and usually I'll have about 40 or so that you can choose from when the time comes, between 30 and 40, usually. All right, project ideas are solicited from ME professors, from local industries. We usually get a couple from like Milwaukee Tool. We usually get some from other smaller companies like Cornerstone Composites has put one in already for this year. You get a general idea there. And then also you guys as students can propose some projects. Like if you're on the Lunabotics team or something, maybe you want to propose a project through Lunabotics, or you have an idea for whatever, a new skateboard. I don't know, just throwing out something there random, but possibly. All right. Once project ideas are collected, we're going to have a meeting later in this term. So this is the first of 2 meetings that will occur in the spring semester. This first meeting is all about just what to expect in senior design. And then in our second meeting, I'll present to you all the project ideas you can possibly work on, and then ask you to give preferences for the projects that you want to work on. And so once I present all the projects to you that you might work on, you're going to fill out a form asking for your project preference, but also what teammates you might want to work on. And I'm going to ask you what's more important to you, the people that you work with or the project that you work on, or if you're kind of indifferent. All right. Then I sit down with a pot of coffee and I match everybody. And I usually have very good matching between what people want, teammate-wise, project-wise, and what they end up getting. It's always turned out way better than I anticipated from the beginning. So, when I first sit down with all this information, it looks overwhelming, but almost always it turns out like way better than I would have thought at the beginning. Okay, so have a little faith in me. I'll match you with a good project, with a good team. Hopefully everybody's happy. All right. Let's talk about the progression, what it typically looks like. So you'll take 4901 in the fall, 4902 in the spring, and they must be taken back to back, and you must work on the same project throughout both terms. In the fall term, usually you're defining the scope of the problem with a problem statement. You do background research. That could involve things like looking at patents, looking at academic scholarly works, looking through books, looking at what products exist on the market. That's called state-of-the-art research, what exists that might solve your problem, that kind of information. You're going to define objectives and constraints for the projects. Objectives are things that you hope that your project and your design achieves. Constraints are things that it must achieve, right? So a constraint must be like, it runs on 120 volt AC power. An objective might be, it draws less than a certain amount of amperage on average, right? Okay, so those are general ideas. Brainstorm initial designs. So this is where you're doing some sketches about like, oh, we might need this kind of mechanism that looks like this, or it might have this shape housing, or whatever the case may be. And then you build up some, rapport of ideas, some log of it. We could do it this way, we could do it this way, we could do it this way. And hopefully multiple teammates are sort of contributing to this pile of ideas. And then you're coming through in the fall semester and saying, all right, what's the best possible option for this portion of the design and this portion of the design? All right, so that would constitute what we call down selection for the design. All right, and there are ways to do that, usually quantitatively with something called a design decision matrix or a Pew matrix. And so that's going to happen in the fall term. Once you've sort of down selected to what you think's the best, then typically you're going to start doing some CAD modeling and SolidWorks, and hopefully by the end of the first term, you've got yourself a nice looking CAD model that you can present for criticism for like an oral presentation at the end of the fall. Then in the spring, you're going to really lock in and finalize your CAD and your design and maybe make some drawings if you need to do that and start building your prototype. So fabrication in the machine shop, 3D printing that, assembling that, ordering materials, that sort of stuff. Build your prototype, test it. You might need some iteration. So, okay, this aspect doesn't really work very well. Let's go back to the machine shop and make this part a little bit better, and so on and so on. Okay, so you're prototyping, testing, building. And then finally, at the end of the spring term, you're going to have a poster presentation where you exhibit your prototype and sort of talk about it alongside all of your peers that have also been parts of groups all year long, that you can finally see what their project is and how that sort of came together. All right. You have some deliverables that are required as part of the process. In the fall term, you have a written proposal that would include like your problem statement, objective constraints, initial design concepts and ideas. And then also at the end of the fall term, we have oral presentations. This happens the Friday of finals week in the fall every single year. You give a 20-minute presentation, and then you have about 10 minutes for question and answer from a panel of ME faculty. So you'll present your design in front of at least 3 ME faculty and probably customers if you have industry customers, and friends and family are invited if they want to come, and you present your design and your ideas up to that point. And then we have some back and forth about, okay, this looks good, try fixing this might need some improvement, etc. Okay. Then in the spring term, you have a couple of things that are due. First is an abstract of your project to the university. So each year the university puts out a booklet full of all of the senior design projects across all of the departments, and you want to make sure that you get your abstract or your sort of project description included in that booklet. That's actually happening right now for this year's cohort. So there'll be a booklet that includes all the project descriptions. And then also you'll have a final design report, and finally a poster that will be involved for this final senior design showcase, which will occur the Friday of finals week in the spring term. Okay, so that's where you're going to exhibit your prototype and your poster. People walk around, and it's a pretty cool thing, right? That's something that's required for all groups. Now, each individual group might have different requirements from their own individual advisor as the process proceeds, right? So your advisor might have individual like weekly worksheets, or might have individual assignments that you need to do related to where you are in the particular design. So each advisor has their own kind of way that they go about advising senior design, since senior design is a bit of an unusual class in the scope of things. So you'll have to sort of follow your advisor's lead there. In addition to that, there are also seminars which occur, and seminars occur weekly, and they only happen in the fall. And the seminars kind of have 2 flavors. Early in the fall term, we have very informational seminars, things like how to do a literature search. We have a lawyer come in and talk about intellectual property and what your rights are as a student to the things that you develop during the senior design process. Those are some of the flavors of the first talks that we have. And then later in the fall term, we start to bring in industry professionals. We have like presidents of companies that come in and talk maybe a little bit more about the business side of engineering. We have an engineer who's been on the job for 20 years who comes in and talks about her career and kind of the twists and turns that her career has taken, and how you might want to view your early career and things like that. So more sort of like professional development type seminars. But the seminars are cool. They're really interesting. We got speakers from Milwaukee Tool, from law firms. I mean, from all over the place. Most of them are alumni, so they've been where you are at some point in their life. Okay, so that's the seminars. Everyone wants to know about grades. How are we graded? Grades are at the discretion of the individual project advisors. So advisors will use a lot of different criteria for giving grades, but it's a little less black and white than you might normally get from an engineering class. And that's just because of the nature of senior design and how it works. So advisors are usually using a combination of like your written reports, your oral presentation, some other assignments they might be giving you, and maybe some of the peer evaluations that you have between you and your teammates. Those might be some of the things that they might base your grade on. And not every student and every team might get the same grade. So you and your teammates, even within the same group, might not necessarily get the same grade. Okay? So that's that. Your grade can also be reduced if you end up missing a bunch of seminars in the fall term. They're mandatory seminars, right? All right. Money. You're going to build a prototype, and there's always questions about, well, do we have to fund the prototype ourselves, or do we get money from the department? And one really nice thing about MSOE in the mechanical engineering department is that we have an endowed fund for prototypes for students. So we have about $1,000 per team, and we have sort of an application process for this. But basically, once you kind of have an idea of what your design looks like and know approximately what you want to do for a prototype, you just write like a one-page proposal to me, I review it, and then you can get up to $1,000 to fabricate your prototype. It's really nice. I didn't have that when I was on undergrad. I had to pay for a prototype myself when I was about your age for my senior design. Kind of sucked. But one nice thing about the ME department is that we have funding for you to build your prototype, which is really kind of cool. All right, and unique. I'd say not every school really has that. All right. All right, last thing for me before I open it up for questions and then hand it off to Dr. Mahinfla for discussion about graduate school is student projects. So if you have a project idea that you would like to work on, you can submit a project idea yourself. And here's the idea, and here's what you need to do that. So if you want to submit a project idea, I need like a 1 to 2 paragraph proposal, which includes a tentative title, and you have to frame the proposal as a problem. Okay, this is important. Okay, so frame it in terms of a problem, not I want to build a skateboard. That's not a problem. That's just you want to build something. Okay, maybe you want to build, like you identify a problem of like, there's a problem when you ride a skateboard in Milwaukee that the skateboard cannot go over the train tracks associated with the hop, okay? And now I want to design a skateboard that overcomes the problem of trying to traverse the hop train tracks. That's a problem, right? And you might frame your concept and your problem for what you want to tackle with the design process in that sort of way, all right? So if you're writing a proposal, it needs to be framed in terms of a problem that is to be solved using the design process. All right. So if you want to have some back and forth about me, about what that might look like, I'm happy to do that. But it's got to be really framed in terms of a problem, not in terms of a solution. Hopefully that's clear. Lastly, you need to have at least one ME faculty who has like looked at your problem statement and has agreed to tentatively advise the project. All right. Once it's prepared, you can email it to me. I'll review it, maybe have some back and forth with you, and we'll see if we can get that project on the books and proposed. All right. The deadline for student submitted projects is about 2 weeks from today. It's 2 weeks from tomorrow, actually, Friday the 13th. All right. So that's that. What's next? We're going to have another presentation about a month from now, maybe 6 weeks from now, where I present all of the projects that you could possibly work on. So like I said, we're collecting them right now. Once I have them all collected, I'll sit down, I'll have a PowerPoint presentation just like this one, where I have one slide per project and we just go through them rapid fire. I talk about all of them, what sorts of things are sort of involved, whether it's, you know, mechatronics, or this is more of an energy project, or this is more of a dynamics and controls project for, you know, people with various interests in various things. Okay? So that's it for the talk here right now. I will make these slides available, and also this presentation is being recorded. I will send out a link to this recording once this is all said and done. So we're going to close the slide deck right now, and I'll open it up for questions if people have any questions related to senior design here right now. I do have one question here in the chat straight away from Isaac. Is the deadline the same for industry submitted projects and problems? No, our industry deadline for submitting call for proposals is March 27th, but you guys have to remember that you guys have a spring break coming up, right? Industry doesn't have spring break, right? Like they have until March 27th free and clear. They don't have a spring break. So the reason I'm saying you guys should get it in before March 13th is because you guys have spring break the week right after that. So I want you guys to get your project ideas submitted to me before spring break, all right? That's the idea. Grace says, will these slides be posted? If so, where? I will just send out the slides in an email to the email list right after this is over, as well as a link to the video recording that we're doing right now. Okay. Alec asks, what happens to the prototypes once the projects are completed? Well, it depends. Sometimes the prototypes go to the industry sponsor. Like if the industry is sponsoring your project, they probably want the prototype in the end. So most of the prototypes from the industry sponsors end up going to industry. Other projects that are like in-house, let's say you're doing a design competition, sometimes those design competitions go to the design competition, wherever it is. Sometimes they stay for showcase. Like, I don't know if you guys have been in Lee's Lounge, but the super mileage vehicles have been on showcase there in Lee's Lounge. Sometimes students take the prototypes home with them, and sometimes they get deconstructed. Like if you build something out of 80/20 framing, for instance, and nobody wants it from your team or whatever, then we'll bring it to the shop. Brett will break it down, and that's how you get a lot of the, free materials in the shop that are kind of hanging out there right when you walk in. A lot of those were probably pieces of previous senior design prototypes. Okay, let's hang on here for maybe another 15, 30 seconds, see if we get any more questions. All right, Caleb asks, can the grants be used for student proposed projects? Yes, the grants can be used for industry projects, faculty projects, student projects. Yes. Maybe hang on for another 10, 15 seconds here, see if we got any final questions. Elijah asks, are there ever projects across majors? Yes, we do interdisciplinary projects across majors. The different programs have sort of different timelines for their senior design process. I'd say ME probably has the earliest project proposal in matching sort of process relative to any of the other programs. Like electrical engineering usually does a lot of their matching sort of in the mid to late summer. Computer engineering usually does it late summer, even into early fall. Industrial engineering does it about midsummer. So ME is usually quite early. And that's good from our perspective, whereas if you want to have an electrical engineer in your project or a computer engineer or whatever, and you want to sort of have it interdisciplinary that way, then it's pretty easy for us to go to the EE department right now and say, hey, can you save us like a student or two to do some like cross-disciplinary projects? Cool. But it's problematic when like there's EE and computer engineering later trying to do their matching like in the summer or late fall, and they're like, hey, Dr. Hart, can you give us an ME student? And I'm like, nope, we're kind of all matched up already. We did that last April, last May, before all the students went away for break. So I'd say if you want to propose something and have a cross-disciplinary project, we can probably grab students from other majors pretty easily, but if you're hoping and waiting to see what other projects might exist in EE or computer engineering or civil or whatever to maybe match with some of those later, I wouldn't think that's easy to do. All right. Well, seeing no more questions, I'm actually going to stop the recording here, and I'm going to